Hi, I'm Karush.
Hi, I'm Subramaniam, and together we are Team ModSpeed.
Did you know that for some e-commerce websites, a 1-second delay in loading its pages could mean up to $2.5 million of loss in a year?
Did you know that about 60% of a website's users will wait only 3 seconds for it to load, after which they drop off, and this could mean a lot of business?
Now we see that the common thread between all of these trends is the page speed. What is the page speed?
In simple words, page speed is the speed with which your website loads. It's usually measured in seconds, but if you're measuring it in minutes, there's something really wrong with your website.
Now that we know what page speed is, why is it important to you as a digital marketer? For an SEO campaign, it means better ranks and associated traffic.
And if you're dealing with paid marketing campaigns, then it means faster landing pages and better conversion rates.
So let's see what are the elements that exactly affect the page speed of your website.
Essentially, there are only 3 things which majorly affect the speed of your website. Let's take a look at what these are.
The funky images on your page, the flashy JavaScript, and the various styling elements.
If you were ever concerned with the speed of your website, then you would have considered simple options to implement, such as
using gzip or unloading unnecessary image metadata.
But somehow, these solutions were simply not enough.
These were major concerns for us as well. And we had the need.
The need
for speed.
And that's how we set out looking for tangible solutions. Solutions that would make a difference. And that's how we found Mod PageSpeed, an Apache server module.
Apache is the most popular open source web server operating system. Now let's take a look at what the Mod PageSpeed module is capable of. It can do smart things like combining several images into a single sprite. This helps in saving the time to fetch each image individually from the server.
It can make a browser save the unchanging elements of your web page so that it does not have to request the server for it time and again. This is called browser caching. For example, suppose your web page requires 3 files to render, out of which 2 are unchanging. With Mod PageSpeed on, your local machine will save the 2 unchanging files on its disk. Thus, the next time that the page needs to be rendered, it needs to request only for 1 file. Let's see what exactly Mod PageSpeed is.
As mentioned by Subbu, Mod PageSpeed is an Apache module that sits right in between the client machine, which is your computer, and the server.
It essentially optimizes the responses given by the server on the fly and delivers it to the client machine, that's your computer.
It essentially acts on 5 major elements of a web page: the JavaScript, the styling elements, various inline and outline elements, and the browser's cache along with the images.
Armed with this preliminary information, we began the alpha phase of our testing. Thanks to the software team, we set up a test server and began testing Mod PageSpeed with default settings installed.
We needed as many different types of websites as possible. To gather the conclusive results, we needed to know that it will speed up all kinds of websites, be it e-commerce, be it lead gen, or be it informative websites.
What basic metrics should be used to measure a website's speed? Size of the page, the number of requests it takes for those bytes to reach your machine, and the time it takes to render that page on your machine.
We wanted cool tools that could help us measure the metrics Subbu spoke about. We evaluated and found out about free tools such as Yahoo's Voiceflow and Pingdom. Let's look at the results we obtained for the metric number of requests. Firstly, to explain the number of requests, let's imagine a web page as a huge jigsaw puzzle.
The web browser requests every piece from the server, so the total number of times that it makes this request is our metric. We looked at the number of request metric for all of our sample set and found that there was no noticeable difference in the number of requests being made with Mod PageSpeed on or off.
Moving forward, we measured our second metric, the page size, which is the total number of kilobytes transferred from the server to your machine to load the entire page.
The e-commerce one website was chosen for being heavy on good quality images and styling. Every metric was recorded over 3 runs as we wanted a large and accurate dataset. Also, having multiple runs eliminates outliers, and once a page that is requested is loaded on a machine, every subsequent load of that page takes less requests and data to render. This is because of browser caching. As can be seen, the results with mod page speed on are not significant for the first run, but subsequent runs have shown a significant drop in the page size with mod page speed on. The Lead Gen 1 website was chosen for being a simple WordPress site with a lot of text-based content. Also, many pages have embedded YouTube and Vimeo videos. But as can clearly be seen, the results with mod page speed on or off are not much different.
Let's take a look at a little more data to consolidate what Subbu observed and which of his observations was closer to the truth. What we see here is only slight improvements across the board and a 5 to 10% decrease in the page size on an average.
Next up is the page load time metric, which simply put is the amount of time taken to render the web page fully. As can be seen for the Lead Gen 1 website, the first run showed a decent amount of reduction in page load time, but not much difference in subsequent runs.
Looking at the other data sets, we saw a couple of similar trends, but overall the results were inconclusive.
So we had run many tests and gathered a lot of data. We expected some solid inferences, but on crunching through the numbers, we had only inconclusive results. Dark clouds were gathering over our experiment, and we were depressed.
But even at the depths of our depression, we never stopped thinking. We kept pushing the envelope till we found our ray of light.
We began Operation Black Viper. We cyberstalked the forums and discussion boards looking for someone who could answer our questions.
That's when we got our man on scope, Jeff Kaufman, software engineer at Google. He was one of the minds behind the module. We made friends with him, and he was good enough to point out some drawbacks with our alpha testing. He prompted us to ask the right questions, which would eventually lead us to the right answers.
We received new directions and learned about new ways to test the module that were just out there beyond our knowledge. Thus began our second phase of testing, the beta phase.
Our learning curve began with re-exploration of the module, but this time our square one was different. We dived right into the documentation, the back alleys of mod page speed.
We learned that mod page speed offered customizations through dedicated filters. It had separate filters for handling images, separate filters for handling JavaScript, and a bunch of other filters that handle things like styling, caching, and HTML elements, bringing the total number of filters to 56.
However, with default installation, we found out that only 27 of these filters, which are less aggressive, are switched on. This was more like a safe bet installation that would show some kind of performance for all websites in general, but to really squeeze out the best of mod page speed, customization was the way to go.
This gave rise to the need for new tools to test out our newfound understanding. We found 2 new methods for testing, a tool that we use every day, Google Analytics, and a method based on every individual page load using another Google product, the web page test.
The GA testing mode was fairly straightforward. On every test page hosted on our test server, we assigned experimental traffic via 3 different routes. The first route employing no mod page speed intervention, second with default filters on, and the third with the very aggressive all filters on setting. And we did this for over 40 test pages.
The 3 primary metrics that were used from Google Analytics were 1. Average document interactive time. This is the amount of time required by the browser to process the page. It is the time elapsed between clicking on the link and the first element of the page loading. 2. Average document content load time. This is the amount of time elapsed between clicking the link and all visible elements of a page loading. And 3. Our usual average page load time, only this time it is averaged over 40 pages.
So let's take a look at the split of the traffic that our test pages got. Thanks to our extended team, we managed a decent traffic to ensure a big data set conducive to conclusive results.
Having done our homework diligently, it was time for the face-off.
Looking at the average page load time, we found something that surprised us. The default setting of the module was doing the worst job and took almost twice the amount of time to load the pages as compared to without any filter.
But this couldn't be right, and there was something definitely wrong with this picture. On digging deeper, we found that 2 test pages were playing spoilsport and were essentially outliers because they took forever to load. Eliminating these two from our further data sets, we found the expected results. After the revision, we found that mod page speed with default filters did better than the other two, while mod page speed with all filters on was not very far behind.
Looking at the results for the first instance load time, that is, the average document interactive time, we found that this time around, on an average over 40 pages, the most aggressive set of filters delivered the first visible element the fastest.
And similarly, the same trend was observed for the metric average document content loaded time. Mod page speed with all filters on outclassed the other two, with mod page speed on default filters coming a runner-up.
Till now, we only looked at cumulative results averaged out to decide on a winner, but we do know that there are hidden performers within these averages as well. So we split the seconds and looked at the loading time in specific time frames. We saw that almost 50% of the visitors routed through the all filter settings got their pages up and running within the first second.
Following it, about 48% of the visitors routed through the default filters got their pages within the first 3 seconds. This confirmed that we had something real on our hands.
And to seal the deal, we needed a winner. It essentially boiled down to the default filters versus all.
With respect to the average page load time, mod page speed with default filters takes the game. But with respect to average interactive element timings, mod page speed with all filters is the clear winner. This means that from the user's perspective, mod page speed with all filters seems to load faster and thus is visually the winner of a page speed contest.
To fully understand mod page speed's customization capabilities and to test the various filters, we needed to go to another level. This hunger was satisfied by the per request testing we conducted using web page test, which allowed us to record granular results for every single run and simultaneously test the various filters to great detail.
Web page test had so many metrics to play around that we had to classify them into 3 categories. The timing category gave us metrics like time to the first byte, time to title, time to start render, and our favorite, load time. The usual metric number of requests was also present, but this time we could really go granular and see the split up for elements like HTML, JavaScript, images, and text. The page size category of metrics provided us exact split for the size of every element, like the size of HTML, the size of JavaScript, the size of images, and the size of text content.
To test the complete flexibility of mod page speed, we created 5 sets of filter combinations, each highly customized. The first one being mod page speed image. This combination had filters that were aggressive towards optimization of the on-page images, but not so aggressive on the other elements. The mod page speed JavaScript. This combination had filters that were aggressive towards optimization of heavy JavaScript, but not so aggressive towards the other elements. Mod page speed all. This was the most aggressive filter combination with all filters available switched on. Mod page speed default. This was the least aggressive with only default filters on. And finally, one with mod page speed turned off.
The way it worked is, web page test allowed us to pit one test page with multiple filter settings against each other and gave us comparative results calculated over 6 runs.
Once all the data was collected, it was time for the final showdown. We hit the nail on the head with the image-heavy e-commerce one website test pages. As can be seen in the timing category of metrics, the load time for the mod page speed image custom filters simply outclassed every other by miles, and mod page speed all scoring a healthy second.
Moving on to the request category of metrics, we saw that being an image-intensive website, the number of requests for images formed a major part of the total number of requests. Here too, our custom image filter combination took the pole position by reducing the number of requests for images the most, with all filters on coming in a close second.
Reiterating this trend was the page size category of metrics, which showed that our custom image filters reduced the page size the most, securing an unbeaten supremacy over the others, while mod page speed all closely followed.
Subsequently, we observed that in the e-commerce 2 test pages, the timing category metrics were being aced by all filters on, with our custom image filter on a close second.
We observed that again in the request category, all filters on showed the most reduction in the number of requests, with our custom image filter on its heels close behind.
But in terms of reduction of page size, our custom image filter showed the most reduction, followed by all filters on.
So Subbu, the obvious question here is, why is this phenomenon happening?
Well, Karush, this is because of the image cache filter that is at play both in our custom image filter and all filters on, leading to images being saved locally on your computer.
We also observed that in non-image heavy cases where JavaScript played a more important role, our JavaScript custom filters did respond to some extent. So Subbu, I think it's time to show all our cards and take the game away.
Take me on a rocket ride. Take me on a rocket ride. Take me on a rocket ride. Take me on a
So Subbu, we clearly have our custom image filters as the front runners for the first place.
Yes, in our case we do, but extrapolating it to the real world, it would not be safe to assume that all web pages will be image heavy. We should rather customize the mod page speed filters to best suit the structure of our website. Thus, mod page speed custom is our final verdict. So having gone through the entire video, what does it mean for you?
It means that you now know of a powerful tool that you can actually use to speed up your website and derive benefits out of it.
But don't you forget to customize it according to the needs of your website.
That's it for now. It was a pleasure presenting to you.
This is Team Mod Speed signing off.